cosine x over 2 is plus and minus the square root of 1 plus cosine x divided by 2. These show up a lot. These you're going to want to know. There are a whole bunch of other identities that are really a little obscure. I'm going to put them up, and I'm going to prove one of them. These are sum and product identities. Actually, you know what? I'm just going to prove one of them. It will probably take the rest of the time here. Here's the deal. The ones that we had in the previous lectures, the addition rules, the subtraction rules, you definitely want to know those. These sum and product rules, these are pretty obscure. However, they're handy. You should be able to look them up in the book and use them. An excellent example, and also proving things is what mathematicians really do. And although not many of you may become mathematicians, a few, and physicists need to prove things as well. Here's what I'm talking about. Here's a sum to product identity. The claim is that sine of x minus sine of y is equal to 2 cosine x plus y over 2 times sine x minus y over 2. And the first thing is let me look and see that I copied that right. I believe I did. So we want to prove this. Which way do we go? So yesterday while we were filming, I decided to just try and disentangle this by using the half angle formulas I just showed up, and a big bloody mess showed up. It was correct, but a lot of times in these, especially in trigonometry, these identities, it's like we're in rural Alaska right now, and there's ways to get down to the river, but if you pick the wrong trail, you can end up in a bunch of thickets. Truth is, by taking these and using half-angle formulas, you just get a big mess. So I had this other idea, and this is what I'm going to do. And actually, I'm very pleased with it because it's a great technique. What I'm going to do is I'm going to rewrite sine x and sine y. Notice that x plus y divided by 2 plus x minus y divided by 2, this is just x. Right? Here's why, because this is the same as x over 2 plus y over 2 plus x over 2 minus y over 2. These cancel. This is just x. And similarly for y, so we can do this. Sine x, oops, let me get this a little better, is equal to this. So I'm just going to do this. This is sine x. And now I'm going to do minus sine y the same way. Well, how do I make y? I can write y as y plus x divided by 2 plus y minus x divided by 2, the same way that I did for x. So this is, what have I got? Sine y plus x divided by 2 plus y minus x divided by 2. And I'm going to put some brackets around things so it's a little clearer. And the reason I wanted to show you this, the book just has a couple of examples, and that's all you really need. The reason I wanted to show you this derivation is because this is a really good trick. Really what this is called is adding zero, or this is the formula, but mathematicians do this all the time. Now remember, the formula for sine of x plus y, and actually I'm going to change it. I'm going to make sine of a plus b, because we have x's and y's everywhere. This is the addition formula. This is sine a times cosine b plus sine b times cosine a, right? This is the general formula. Here's going to be my a and b, and this one, a and b, and this one. So now I'm just going to follow the formula. So this is sine of x plus y over 2 times cosine of this x minus y over 2. And still coming from this is going to be plus sine of x minus y over 2 times cosine of x plus y over 2. That's incorporating this formula. A and b respectively are a and b. Now, I need a subtraction in a big parentheses. This is going to be, now notice x plus y is the same as y plus x, so I'm going to write this as sine x plus y over 2 times cosine y minus x, and now I'm going to fix this, but not yet. X over 2, and it's going to be plus sine of y minus x over 2 times cosine y plus x, but I'm going to write it as x plus y over 2. Okay, so here's what we have. We put the minus sign through. We're going to get minus in front of both of these signs. So this is minus this, and this is minus this. So look what I got. I got sine x plus y over 2, cosine x minus y over 2. Here's the deal. Y minus x over 2 is equal to negative x minus y over 2. But remember, cosine of minus x, or whatever, minus whatever, is cosine x in this case. Cosine kills off this negative. This is going to be precisely the same as this term right here is going to be the same as minus sine x plus y over 2 times cosine x minus y over 2. It's very important that you understand this transition and rewind this if you need to. But the nice thing is look what happened. These go away. So now I have this. I have sine of x minus y, cosine x plus y, sine of y minus x. I got a minus sign. Y minus x over 2 is the same as negative x minus y over 2. But sine of negative x equals negative sine of x. This negative sign is going to come out of here. This will become minus minus or plus sine x minus y over 2 times cosine x plus y over 2. So what do we got? One of these, we have two of these. It's written 2 cosine x plus y over 2 sine x minus y over 2. You just switch these terms around. So here's one of them, here's two of them, and that's done. This is a really good thing to be able to work through. I would try and spend a little time with this if you can. Let's see. There's an example in the book. We'll see if we got enough time with this. Yeah, we're getting close. The producers saying we got about a minute on this one. Okay, this is a different formula. This is a product to addition formula, I believe they say. I just want you to see how to do this. One of the homework problems says convert sine 3x cosine 5x to something that looks like this. This is a plug and chugger. This is just 1/2. Here's x, here's y, whatever's inside here. So this is going to be sine 3x plus 5x plus sine 3x minus 5x. Okay, and this is 1/2 sine of 8x plus sine of minus 2x, but the minus comes out, so this is 1/2 sine